The chapter P, the prereq chapter, is basically a review of algebra skills. Now, because the last couple of years have been weird, right? Like you guys were in Algebra 1 during COVID. So there might be some holes as we go through this chapter, right? All that stuff, I'll generate some like extra content, like maybe extra reviews, stuff like that. And I'll put a page at the top of the module that's like a review of those skills. And so that if you need to go back over those things, those are opportunities for you to do that. So you might have to do a little bit of extra work to fill in those gaps, okay? But I'll provide you with that so that at least if you're feeling like you fell behind, we can catch you back up, okay? So today's topic is exponents and rectangles. So we start with some basics on integer exponents, okay? An integer exponent allows us to repeat multiplication. So if you saw something like a to the fifth, that means a times a times a times a 5 times, okay? If you saw negative 4 to the third, that would be negative 4 times negative 4 times negative 4. And then if you saw 2x to the fourth, that means 2x times 2x times 2x times 2x. Now, the most important thing I would say on this slide is knowing the difference between negative 4 to the third and negative 4 to the third, like that. Who could tell me the difference?
So if you have negative 4 and it's in parentheses to the third, you're going to multiply, basically you're going to multiply the negative 4 times the negative 4. But if you have the negative 4 without parentheses around it, basically the second option, you're going to apply the negative after you do all the 4 multiplying.
Perfect. Okay? So the negative, good job, Claire, inside the parentheses means it stays with the number or stays with whatever's inside there. That stays with it the entire time. And you would do 3 of those or 4 of those or whatever it is. The negative without the parentheses, okay, means it's the last thing to get applied. And to be honest, in this example, it doesn't matter because it's an odd exponent, right? Both of those are going to be negative 64. But if that was negative 4 to the second, one answer is going to be a positive 16 and one answer is going to be a negative 16. Okay? Standardized tests love little stuff like that because it'll get you. And it seems like it's pretty easy and it's something that you can make an easy mistake on. Okay? Questions on that? All right. Exponential notation, and this is something you already know. It just has a name, okay? If a is a real integer and n is a positive integer, then a to the n has n number of factors, so you just repeat a. So this is just called exponential notation. When you write something with an exponent, that's what it's called, okay? That's what its official term is. N is the exponent, a is the base. So whatever is being raised to the power is the base, and the number at the top, that little superscript number, is the exponent. And we read it as a to the power of n or a to the nth power. You can read it either way. When you're multiplying exponential expressions, we add the exponents. So if I'm multiplying a to the m times a to the n, it becomes a to the m plus n. This only works if the base is the same. So I can only combine these two expressions because these both have the same base. If I had x to the third times x to the fourth, I keep the x, so I leave the base as it is, and then I add the exponent, so it'd be 3 plus 4, which is x to the seventh, okay? If you're ever questioning it, you could simply write this out as x times x times x times, and then 4 of these, and then you could literally count them. There are 7 total x's, okay? So if you're ever like second guessing yourself, am I supposed to add the exponents? Am I supposed to multiply the exponents? Do I change the base? You can always expand it. Obviously, if it was something like to the 12th power, you wouldn't want to, but you certainly can to double check yourself. All right, let's see if we can do these examples. So a, b to the 7th times b to the 4th, what are you going to get from that? B to the 11th. B, 3x squared times 4x to the 3rd. What happens here? 12x to the 5th. Good. So the 3 gets multiplied by the 4. You can regroup this in any way because it's multiplication, so you can regroup it. The 3 gets multiplied by the 4, and then the x squared gets multiplied by x to the 3rd, and so we add those exponents.
Just a quick question, it's gonna sound kind of dumb, but in questions you go like this.
God bless you.
You would go like this.
Usually
this.
I go this way. Yeah.
Because I go down.
That's fine. It doesn't matter. I mean, that's how the notes will be, but
I was C. I thought it was.
it doesn't matter. All right, what's C?
Negative 12.
Good. What's D?
Negative 15.
Nice. What's E? Good. And F? Good. Who got them all right? Okay, questions if you didn't, maybe we went too fast, but any questions?
We went
A little too fast.
yeah.
Yeah. Welcome to Algebra 2 Honors.
I have a very late reaction time.
I say that with all the love. All right, so there's a lot of different ways to do these, and you kind of get to choose which way your brain sees it. For me, I would probably look at the positive and negatives first and get rid of those, right? So I have a negative on the front here. The 3 is positive, and I have a negative here. So I can separate those out as negative ones if you want. A negative and a positive and a negative. There's an even number of negatives, right? So what happens to the negative? It goes away. So my answer is going to be positive, okay, whatever it's going to be. Then I can look at all the numeric part, and you can, again, you can rewrite these if you want to. I can separate out all the coefficients. So 3 times 2 would be 6. Should keep the color, hang on, 6. Okay, then I can go, okay, let me look at all the x's. There's an x to the second. This would be an x to the first, and then an x to the third. If I add all those up, I get x to the what?
6.
Good. And then I can look at all the y's. Y to the third, y to the second, and this would be a y to the first. So 3 plus 2 plus 1. Again, I get y to the sixth. So my answer would be 6, x to the sixth, y to the sixth. Now, there are going to be questions in your homework that you can do in your head, and I know what those questions are, and I don't expect to see a lot of work. And then there's questions that I know you should not be doing in your head, and you need to make sure you're showing that work, okay? So sometimes you guys think you're very, very smart, and sometimes you are very, very smart, but that is usually when we make a silly mistake. So just make sure, that, especially the longer ones, that you're showing your work so that you can get full credit for the homework. All right, next, yep.
How do you get the positive 6?
For the coefficient?
3, yes. It's no, not yes, the coefficient.
This one? Oops, a daisy.
The positive 6.
At the front, you mean? Yes? So it's, how is it positive or how is it 6?
How is it? Well, kind of both.
Both, okay. So the negative, this would be a positive times a negative makes it positive. And then this would be a 1 here. 1 times 3 times 2 gives you the 6.
Oh, okay.
Good?
Yeah. Let me. Positive, right? And then
Yep.
that would be a positive.
That's positive, right? So if there's an even number of negatives, it's going to be positive, right? Because the negative times the negative is positive.
There you go. Now I have more of a certain footnote in my head.
So thinking of that, right now go to B. You've got a positive, a negative, and a negative. So my answer is again going to be positive. And then I go to the coefficients. 5 times 3, that would be 1. So this is 15. And then I have an A here, right? I don't have it on the beginning, but I have an A here and an A here. So A to the second times A to the third becomes what? A to the fifth. And then I've got the B, B to the fourth, and B to the first, which makes it B to the fifth. Good. Everybody still good? Yeah? All right, so now we've got two things happening. You've got the multiplication, but then you also have something being raised to the power, and the power's on the outside. So be careful here because that power, that last 2, this 2, only applies to this parentheses, right? It's not like we multiply it out first and then we raise it to the power. You've got to just raise just that 1 to the parentheses. So what is negative x times negative x? Oh, so close. Negative x times negative x is what? How many x's are there? 2. So it's positive x squared. Now I go the step further, and I've got negative times a positive, which means my answer is going to be negative, and I have x squared times x squared, which is? Good. So this would be negative x to the fourth. So that this part, right, this, we squared this, right? So this becomes this. Negative x times negative x. It's a negative times a negative, so it's positive. And it's x times x, so it's x squared. So that was this part. Then I brought this down here. So the negative stays on there because it's not, the 2 isn't on the outside of the parentheses on the first one. So this is a negative times a positive, which means my answer is negative. And then it's an x squared times an x squared, so it's x to the fourth. You're welcome. All right, now go to the next one. So negative x to the third, the second one has the 3 on the outside, right? So this is negative x times negative x times negative x, which means that second parentheses would be what? Good. Negative x to the third, or negative x cubed, and times negative x to the third. Not negative. Positive. Good. Positive x to the 6. Yeah. Okay, now we take it to the next step. You've got multiplication in with addition or subtraction. So we're going to combine the like terms. So the first thing we're going to do is multiply, and then we're going to combine our like terms. So if I look at A, what's the result of just the 5x squared times the 2x to the third? 10x to the fifth. Good. Plus, what's the result of the second one? Perfect. Now, only because they both have the x to the fifth, right? If it was an x to the third and an x to the fifth, we could not combine them. We'd be done. Only because the exponent on the variable is the same can I now combine these. I would add the coefficients, and I'd get 22x to the fifth. So you're combining like terms there. Again, if it was like x to the third plus x to the fifth, you would keep them separate. Now go to B. What's the result of 3 a to the fifth times 5 a to the third? Good. What's the result of, and this is a minus now, 6 a to the second times a to the sixth? Good. Can I combine these? Yes, I would get? Perfect. Questions on that one? All right, so on that note, now we're raising a power. So we've added or combined like terms. We've multiplied with exponents, and now we're going to raise a power. So we're raising a power to a power. When you raise the power to a power, you multiply. So if I had something like x to the fifth, or sorry, x to the fourth, raised to the fifth, we multiply the exponents, and I'd get x to the 20. Again, if you questioned it, you could always write out x to the fourth, x to the fourth, x to the fourth, x to the fourth, x to the fourth. I wouldn't recommend doing this every time, right? Because it's an entire waste of time if you know the rules. But you could do that, and then you could say, okay, now I'm multiplying. I just have to add them. 4 plus 4 plus 4 plus 4. 4 plus 4 plus 4 plus 4, and you'd get to the 20, okay? If you had to expand it further, you could even do that, but hopefully we just remember the rule that if we raise a power to a power, we multiply. All right, what'd you get for A? Good, 8x to the third. So the 2 is being raised to the third, the x is being raised to the third, or it is 2x times 2x times 2x. So you can distribute that exponent there, okay, or you can rewrite. What you cannot do is distribute an x if it's a plus in the inside. So like if you saw something like 2 plus x to the third, that is not the same thing as 2 to the third plus x to the third. What would you do in that scenario? You've got to take that and you'd multiply it by itself 3 times, and then we FOIL, okay? So this would be 2 plus x times 2 plus x times 2 plus x. So be careful with the difference between those two, right? This does not have a plus or minus sign in between, so we can distribute. and the other one does have a plus sign in between, so you cannot distribute. You would have to take those, multiply it 3 times, and then first, outer, inner, last 2 parentheses at a time. All right, go to B. What'd you get?
4x is 25.
So raise the power to the power means to multiply. So the 2 gets the 2, which is 4, and then x to the 5th, the 5, I'd multiply by the 2. So it should be 4x to the 10th. How about C? Good. Still stays 4x to the 10th, even though it's negative on the front, because a negative times a negative, or negative 1 to the second would make it positive. Yep.
So you have to so to do this you have to elevate the first number and the x. So you have to do negative 2 times.
So your 2 choices are making it negative 2 to the second and then x to the 5th to the second, like that. Distribute the exponent to each term. Or you can write negative 2x to the 5th times negative 2x to the 5th and then multiply it out. So whichever way your brain makes sense of that, you choose. Okay, you could do it either way.
Makes more sense.
All right, D. Good. So the negative 2 gets raised to the 3rd. That gives you the negative 8. And then the x to the 4th, the 4 and the 3 get multiplied together to give you the 12. All right, E. Good. So the negative 3 got raised to the 3rd. That's where negative 27 comes from. The x to the 2nd got raised to the 3rd, so we multiply those out and I get 6. And the y to the 5th got raised to the 3rd, and we multiply those exponents out and you get 15. And does this change? No, this is probably a total typo. There was probably supposed to be something on the outside, so we're going to add something on and pretend it was there the whole time. We're going to make this to the 4th. What happens now?
It should be
Positive. X to the 4th. Y to the 8th. Good. So if it was an odd power on the outside, my answer would have been negative. But because it's an even number on the outside, my answer is positive. How are we feeling?
Nah, well, kind of lost. I would
Oh, boy.
prefer to do 10.
All right, we're actually going to save A and B for tomorrow, okay? We'll start the day with those, like as a kind of like a review warm-up. We're going to go to C. So now we've got multiplication again, and then we're combining like terms, right, if we can. So I'm going to first take care of this first parentheses, okay? The 2 gets the 3rd power, which means this is 8. And then the x gets the 3rd power, so that would be x to the 3rd. I'm going to keep it in parentheses so that I remember that it's separate from the next terms. The next one both gets the squared, so this becomes x squared and y squared. Then I go to the next one. There's no exponents on the next one, so you can either rewrite it or you can start the next step. It's okay. It doesn't really matter what order we do that in because they're separate until we combine them at the end. If there were exponents on these here or here, I would have done it in that step. All right, so now I want to multiply out like the purple and the teal. So the purple, I'd get 8 because there's only one coefficient. X to the 3rd times x to the 2nd, which is x to the 5th, because we add when we multiply. And then y to the 2nd plus 4. That would technically be 4 times a negative 1, right? So this would be a negative 4. X to the 2nd and x to the 3rd is x to the 5th. And then y to the 2nd. So now this is really 8x to the 5th, y to the 2nd, minus 4x to the 5th, y to the 2nd. Are those like terms? Yep. So I do 8 minus 4, and I get 4. Leave my variables alone. X to the 5th, y to the 2nd. Okay, last slide. So for A, we're raising a fraction to a power, right? And again, your brain can see this two different ways. You can literally, which is probably not what I would recommend, but you can rewrite that fraction 3 times. So I could do 3x over 2y times 3x over 2y times 3x over 2y. And then I can multiply straight across in the numerator and straight across in the denominator. So the numerator would be 3 times 3 times 3, or 27 x times x times x, x to the third, over the denominator would be 2 times 2 times 2. 2 times 2 times 2 is 8, and then y times y times y is y to the third. So that's one way to do it, totally acceptable, get you to the right answer. Okay, if your brain sees it that way, do it. The other way to do it is to take the exponent on the outside of that fraction and distribute it into each term on the inside. So this 3 is going to go to the 3 is going to go to the x, the 3 is going to go to the 2, and the 3 is going to go to the y. I can only do this because it's a product in the top and the bottom. If there was an addition sign in the top or the bottom, you can't do it this way, okay? Only because it's just a product. So 3 to the third gives me 27. X to the third is x to the third. 2 to the third is 8. And y to the third is 3. It's faster, but it gets you the same answer. So if your brain likes the first way, stick to it. All right, we talked about this at the beginning. Let's see if we remember. What is the difference between b if it was in parentheses and now it's not in parentheses? Because it's not in parentheses, what's my answer? Because it's not in parentheses, it's negative. So it's negative 16. So this would be the same thing as saying negative 4 times 4, which is negative 16. So not in parentheses, negative's the last thing. For C, does it matter? No, because it's odd, right? This would be negative 64. But really, that should be negative 4 times 4 times 4. That's the right way to get to that answer. What's D? Positive 16. And do we remember what raising a power to 0 does? 1. Good. Any base raised to the 0 power is 1. So you could have like the longest, most complicated to the 0 power, it's 1.
Infinity to 0.
Well, you're not going to raise infinity because it's not going to have you raise a number that you can't define, but it would be 1. Questions? Survived. First day. Algebra 2 honors notes. Take a deep breath, okay?